Thank you for the kind introduction. Thank you also to the local organizers for taking us to Tbilisi. Unfortunately, not physically. I would have loved to go to your beautiful city and enjoy all your excellent food, but must be some other time. Anyway, yes, my task was to talk a little bit about method validation. That's a big task, a big subject, but in this case, in relation to accreditation requirements. And I'm going to take you through some issues here. I will actually dig back to a little bit to the historical background of talking about validation, because that's interesting to see how this was dealt with 20, 30 years ago, but also because it puts emphasis on the understanding of the concepts of validity and validation and verification. And of course, we have talking about accreditation requirements. We have to talk about the latest version, the 2017 version of the 17025 standard, looking into the requirements for validation and verification for those who want to be accredited based on that standard. I will not read the standard for you. Hopefully you have done that yourself if you're in a business where you are accredited or seeking for accreditation. But I will try to look a little bit between the lines of the standard. That's what I normally say, where you find the most important information, because that's certainly a generic standard which takes some interpretation, and it has to be interpreted in every single case where it is used. And taking that further to how we can deal with these interpretation of the requirements, I will dig a little bit into some issue which has been important for us lately, and that's the extent of validation. How much do you have to do? And I will, of course, take you finally to the Eurachem guidelines, where you can find a lot of details on how to deal with validation and verification. And then very finally, I will just have a few comments on what you're looking into now in future challenges. So going back to the 90s, this concept of validation and validity was introduced gradually in various guidelines and articles and texts. There was something called the Valid Analytical Measurement Principles, the VAM principles, invented in UK back in the beginning of the 90s. In the end of the 90s, Eurachem issued its first fitness for purpose guide. We will come back to that, of course. But interestingly enough, and I know from experience, because I was quality manager of a laboratory those days, being accredited, and there was no formal requirement, or at least no formulated requirements in any of the standards which was used as basis for accrediting laboratories. One of the documents used as basis was the ISO Guide 25, General Requirements for the Competence of Calibration and Testing Laboratories. Not quite sure about its origin, but I think it stems back from around the middle of the 80s, where it says that testing shall have adequate document instructions on standard testing techniques, where the absence of such instructions could jeopardize the efficacy of the testing process. Documented instructions, adequate document instructions, which must just jeopardize the testing process. That's how far we can get in relation to talking about validity, but doesn't mention the concept of validity or validation at all. Still, it was stated in the introduction to this guide document that it could be used as basis for approval of laboratories' competence when the accreditation body wanted to assess them. Further in the 90s, we started in Europe, actually all the way back from 89, the beginning of 90s. Sentinel in Europe started up building elaborating some specific standards, and one related to this subject was EN 45001, general criteria for the operation of testing laboratories. Doesn't talk about competence, but criteria for operation. Although it was still very much copy-pasting from the ISO guide we just saw. One interesting point was though added in the text there, and that was a phrase here, that the testing laboratory shall reject requests to perform tests according to the test methods that may endanger an objective result or have a low validity. Whoa, suddenly there was the word validity coming up there. And some ABs accreditation bodies started really requiring method validation from the laboratories as a precondition for being accredited. I know, as I said, that from experience back in the 90s in Denmark, where we were working hard on understanding what was this all about. There was nothing about it in the standard, but how could we do method validation without having a specific requirement for it? Well, yeah, there was somebody helping us by issuing what we called the yellow danger at that time. Some of you may be as old as me and remember these yellow documents issued by the Association of Accreditation Bodies in Europe. They were printed on yellow paper. They were allegedly guidances on interpretation of the standards or the ISO Guide 25, but in reality, they often became requirements to us laboratories in the hands of the assessors. So that's why we call them the yellow danger, because I mean, they were not only beating us with the standard, but also with these additional documents. And in that one, there was a specific chapter on validation finally. But again, not mentioned in the standard. Not until this came up with the issue of the ISO IEC 1705 standard in the year 2000, general requirements for the competence of testing and calibration laboratories. Sounds like the title of the ISO 25, ISO Guide 25. You may notice a little difference. It's mentioning testing before calibration for some reason, but there might be some source behind that. I don't know. Anyway, another thing is here now, it's becoming a conformity assessment standard. It's one of this ISO 17000 series of standards, which are dealing with conformity assessment, meaning procedures how to safely assess and judge on whether some specifications are fulfilled. There are a number of these standards. And in this one now, there is certainly now, finally, in a standard used as basis for accreditation, a section on validation of methods. You probably are aware of that. But at the same time, I mean, we talk about this in the context of validation. I would certainly like to highlight that the 17025 is not the accreditation body's standard. It's a laboratory standard. It's made for the laboratories. It's made for the laboratories to have some good common practice on how to ensure that you can fulfill the requirements of your clients to give them good quality testing results. Well, yes, it is also mentioned in the introduction to the standard. It can also be used as basis for accreditation, but that's not the main purpose in principle. Another thing is that, as I mentioned in the introduction, that certainly this is a generic standard and it's subject for a lot of interpretation in the many specific situations it is applied. And I should also like to highlight that when this standard is, as you probably know, referring to building up a quality management system. And it is, of course, related to providing and proving that your laboratory is technically competent. But it also goes on the more kind of non-quantitative measures of competence of services to customers, about the reliability of the results and the fitness for purpose of the results delivered to the customers for them to make decisions based on those results. And that's exactly why also dealing with valid methods and using valid methods for providing those results is so important. When we looked at the different references back before the change of the century, back in the 90s, the talk was mainly about validity. Not until we finally issued the 17025 standard in 2000, there was suddenly a more focus on validation. Well, I hope that we can all agree then that we talk about validity, we are talking about fitness for purpose of a method for whatever it's going to be used for. And this fitness for purpose of the method can be obtained through a validation process. And that validation process must fulfill three purposes: ensuring that the method is appropriate for solving the task for the given client, whatever kind of samples and complicated matrices in these samples he is bringing to the laboratory. the method must be capable of dealing with those samples. And then, as many people probably see, as the primary purpose is to give reliable results, because these results are going to be used for decision making by the client. But I would also add a third purpose, which is more internal for the laboratory dealing with the method, that the validation, or as we should see also the verification process, must serve the purpose of making the laboratory well acquainted with the performance of the method, getting to know the method, how it works. So maybe here we should focus more on, I mean, the focus has been very much on validation, but maybe we should focus more on the concept of validity, ensuring that the method we are using is valid for solving the task, giving reliable result, but also that we can safely perform that method routinely in the laboratory in our daily work. And the validity of the method must be ensured either through the validation, if the method is not already valid. If it's a newly developed method, we must do the full validation to ensure validity of the method. That must be documented. Or if it's already a validated method, a valid method, we must verify that this is still valid when we are applying it in the laboratory. So I mean, this is certainly my little point now in relation to this, that I am very much focused on talking about validity instead of talking about validation. Let's look at some definitions. The terms validity and valid cannot be found in the Vim where we normally find the terms and concepts we are using in our context. So I had to look out to a more general dictionary where we can find the formulation that the quality of being well-grounded, sound, or correct is describing what it means to validity means. And something being valid means that it is appropriate to the end in view. It's effective. But that's exactly what we mean by it. It should be fit for the purpose. So here we are back to the fitness for purpose interpretation of this word. It becomes a bit more tricky when we look at the definitions of validation and verification. For quite some years, more precisely since 2012, has been common practice to use definitions from the Vim standard. That validation is some verification where the specified requirements are adequate for intended use. Well, that takes some speculation and thoughts and interpretation what that means. But it's also clear here that the definition of validation is actually based on the definition of verification, where it talks about provision of objective evidence that a given item fulfills specified requirements. I haven't got the time for going into the further details of that, but I will take you to some interesting development lately. And that is that here in 2020, the basic standard in the 17,000 series of conformity assessment standards also make some definitions where it talks about confirmation of plausibility for a specific intended use and so on. And also the verification has been redefined. Confirmation of truthfulness through the provision of objective evidence. My little arrow here disappeared because one of the things, and I like that, is that we don't have to confuse the two definitions anymore. The definition of validation is not based on the definition of verification. There are two separate definitions. And as I see it, this change in wording here, confirmation of plausibility, confirmation of truthfulness, goes along with the new approach in the new version of the standard, where we are very much talk about risk assessment, knowing that nothing is really black or white. It's assessing what are the risks if we do so and if we not do so, and building up something which is plausible or truthful. Another thing is, of course, that we are still very much focusing on intended use. We're focusing on the specified requirements for this intended use, and we are still talking about the necessity of providing objective evidence that these requirements for the intended use are fulfilled. Both if we start out with a new method, have to validate it, or if we just have to verify an already validated method. So, of course, talking about method validation, taking this into this full term of method validation, not only validation, of course, the situation of a laboratory using a method to solve a problem for a customer or a client, providing some evidence that this method is acceptable for its intended purpose and gives results which can be used by the client for making reasonable decisions. You are probably also aware that we are talking about different categories of methods in this context. Standard methods, which are already validated, they will require verification in the laboratory. The description of the method is fully in place, but it could be a good idea maybe to elaborate some internal SOPs for the current performance in the laboratory. There are the modified standard method, where we need to change the method a little bit for a specific purpose. And of course, here we have to do some additional validation to ensure that this is still fulfilling the intended use of the method and giving results as required. This is certainly where we start changing the method a little bit, where we should certainly think about making some internal SOPs. And then we start from scratch sometime, having to develop things from scratch. And of course, here we talk about full validation, and we talk about us having to put up the method description. Little interesting thing here is that in the new version of the standard, the 2017 version, this approach of verifying methods is, wouldn't say giving priority, but it's mentioned before start talking about validation of methods. So probably it's the view is that this is the most common approach to start out by having standard methods and verifying those. As I said in the beginning, I will not read the standard for you. I will just make a few quotes here, and you can mainly read them yourself. And from this initial subsection on this issue in the standard. Interestingly, the standard doesn't mention standard methods. It talks about using appropriate methods. And it's talking about using methods in the latest valid version. And whether that's always a standard method, I don't know. I mean, actually, it does the opposite. It talks about non-standard methods in some other sections. Another thing we can identify here that it certainly as a method, the method should also describe how we estimate measurement uncertainty and how we use the statistics for this. So that should also be validated and verified in those cases. And certainly it also interestingly here mentioned by the end that the application of the method shall be supplemented with additional details to ensure consistent application when it is appropriate to do so and necessary to do so. And that's what I already mentioned, that we have to, in many cases, to come up with our internal SOPs, how to perform the method in lab, not to change the text, certainly not, then we have modified the method, but just to ensure that we can follow the standard method correctly. And that's what can come out of a verification study. Laboratories should verify that it can properly perform methods, and maybe we should have a SOP describing how we do that. There's no specific requirements on how this verification should be done, but going back to the definition we just saw a few minutes ago, we must provide some objective evidence that in our laboratory, using that method, we can still fulfill the specified requirements for that specific use of the method. And as I said before, the verification study is a very good exercise in getting experience with the performance of the method, identify any difficult risky parts of the process, so we're not surprised in the routine use of the method, and not being able to perform it consistently. And we, in that case, should certainly elaborate our internal SOPs for this purpose. Validation of methods.
Sorry, Lorens, Lorens, just to let you know, you have about 5 minutes.
I know, yeah.
Okay, that's
Thank
fine.
you.
Okay.
Yeah. It says that the validation shall be extensive as necessary to meet the needs of the given application of the method. It mentions that in sampling and sampling handling can be included. And it suggests that it can either be through comparison or in-house validation. The performance characteristics are mentioned, yes, and it's to ensure fitness for purpose. Talk about the performance characteristics. Well, they are only mentioned in a note. They are not mentioned as a direct requirement. So we still have to evaluate what is relevant and necessary in our case. Some of these are very well-known characteristics. Always a discussion about measurement uncertainty, whether that's the characteristic of the method or the results coming from the method. I will refer to an upcoming guide from Eurachem where they're talking about measurement uncertainty estimation based on validation data. And I will also highlight here that it talks about cross-sensitivity against interferences, the whole issue of being aware of matrix effects when you do your validation. That's important. So how much should be done? Well, there are some considerations about this. Some sections you have a tradition for doing things in a specific way, and you do that. But you always have to evaluate what should be done, how much should be done. And in principle, this should be defined or determined by communication with the customer, what is needed in this specific situation. But we have to admit that validation, as this is a quote from the old version of the standard, unfortunately not there in the new anymore, because I like that validation is always a balance between costs, risks, and technical possibilities. And that's what we are looking into very much now. What and how much must be done? Talking about a validation or verification study. What is the question of which of the performance characteristics should be really deal with in this verification or validation study? And that may involve some risks taking. How much should be done? That's a question of the number of experiments to be done. This can be determined statistically, and we can talk about power of tests and things like that. And we basically have a balance between rejecting a method which was, well, in reality valid, or vice versa, accepting a method which was not valid. And that's always a delicate balance, and will always involve some kind of risk. So that's where I will guide you to look into the Fitness for Purpose guide from Eurachem if you don't already know it and have it on your laboratory desk. It's on its way in the 3rd edition. Right now we're working hard, and there will be some changes. I promise you should look out for the new one coming. Cannot tell you exactly when. We are still working hard on this. We can also say that we have issued over the last years some additional supplementary documents which cannot be seen as standalone documents, but are supplementing the basic guide, referring back to the basic guide, something on planning and reporting validation study, and Vicky will come back to the lecture on that later today, this afternoon. Use of blanks has become an issue which we think could need some further explanation, and right now we're also working on 2 new supplements on this issue of extent of validation, and something about dealing with response curve, not only in relation to calibration, but also in relation to the working range of a method in general. So look out on the website where these documents will appear, and they will always be free for download for you. Just finally mentioning that we are lately also looking into if we can talk about validation of the sampling process, validity of the sampling process. We have established a joint task group with Eurolab, and we are hoping that we can elaborate some guide on this. It's certainly a tricky challenge, because it would be easy if you could see the whole process from sampling to the final issue of a result as one integrated combined process, but we know that often the sampling is done as a standalone activity, and how can we validate that? Other issues on our agenda right now is looking about the fitness for purpose of analytical equipment engaged in an analytical method. We are aware of this new, what I call the gray zone between microbiology and analytical chemistry, the bioanalytical methods, which in some cases also may require some new ways of talking validation and verification. And not last but not least, we have lately been engaged also in talking about non-targeted method. We established a little task group on our method validation working group, where we'll be looking into this also challenging task, because there we have really to deal with a lot of data.